our parabolas were at 0, 0. Today, our parabolas will be at, I don't know that I want to say centered. I want to say a vertex. All right, parabolas with a vertex at HK. All right, HK is just any point, okay? We're starting to move these parabolas around. H is your X, thank you. H is your X value, and K is going to be your Y value. All right, so I'm moving them around. They're still going to be either opening up and down or left or right. Okay, so that's not going to change. They're still going to be opening those ways. Okay, and it's really a lot like the ones that we looked at yesterday. We just have this HK to deal with now. So if we have a vertical axis of symmetry, our standard form is x minus h squared equals 4p times y minus k your vertex is at HK. Something that you need to notice is x minus h, it's y minus k, but your vertex is at HK. So if it says like x minus 2, then it's just 2. Okay? If it says x plus 2, then it's a negative 2. Alright? Because that says minus, that does not. Okay? So your vertex is at HK. Your focus, remember your focus, that's that point that's inside that parabola that everything goes to. Your focus is at H, comma, K plus P. Look back on your notes from yesterday at your vertical axis of symmetry, the one where X was squared. Where was the focus yesterday when X was squared? At 0p. Right? Our vertex was sitting on 0, 0, and our focus was 0p. So really the focus hasn't changed here. Alright? Yesterday it was at 0, 0 was the vertex, and the focus was at 0p. Today it's at HK, and it's at HK plus P. It hasn't changed. Yesterday it was 0, 0, and then it had to move up P units. Today it's at HK, and it still has to move up P units. So it hasn't changed how we're doing it. It's just changing the numbers. Yesterday it was 0, 0. Oh, that's a 5. Okay, so it's going to be 0, 5. Today, let's say it's 2, 1. That's a 5. Okay, well, it's going to be 2, 6. You still have to add that amount to it. It doesn't change it. Yesterday, when x was squared, what was the directrix? Y equals what? Negative p. Okay? So you had to basically subtract p from 0. Here, it's at y equals k minus p. You're still going down p units. It's just that you're starting at some place other than 0. So you have to write it out. P is positive. That hasn't changed. If P is positive, it opens up. If P is negative, it opens down. Alright, so that's HK. This didn't go over any, so it's still at H, but it went up P units, whatever P is. If it's 2, it went up 2. If it's 11 million, it went up 11 million. Good luck graphing that one. Okay? This is still just a horizontal line, so it's 5 equals. But where does it start? Well, it's whatever K is minus P. It's P units away from that K. So if K was like 12, then I had to go down 12 right here, and I went up 12 right there. That vertex is exactly in the middle of those two. It's exactly in the middle. And this is P greater than 0 or less than 0 on this one? It's greater than 0. How do you know? It's opening up, right? See, I think I can squeeze one in right here. This corner. If I have more room to write, I put it right here maybe. No, that's gonna run into my, anyway, doesn't matter. Alright, so this is HK. This is still H and K plus P. Now, how did I add P to that, but it ended up going down? It's a negative. When you add a negative, it's smaller. You get something smaller. So that's how it ended up. P is less than 0 over here. That's when I added, like if P was negative 4, if you add negative 4, you're going to have less than you started with. This is y equals K minus P. There. Because minus and negative gives you a positive. Alright? Alright, so we still have a center at HK, but this, or not center, a vertex. But this time we're going to have a horizontal axis of symmetry. Horizontal axis of symmetry. Still, we have a vertex at HK. That's not going to change, okay? That will not change. What will change is what's being squared. That's our equation in standard form. Be careful when you're trying to write out what the vertex is. It's really easy to get HK on this one because HK, like that's how you read it. You see the H, you see the K. And on this one it's kind of backwards. Just remember that H is going to be with X because H is your X term. H is your X term. H comma K, X, Y, X comma Y. So your H is with your X, your K is with your Y. That did not change. Where they are, that changed. But just what they're with, that did not change. Okay, so we got the vertexes at HK. You know that. It's not at 0, 0 today. It's at HK. So after what we talked about yesterday with the focus, and what we just talked about with the focus, with the center at HK, when X was being squared, where do you think the focus is on this one when Y is squared? h plus p, comma k. Yeah, because remember yesterday it was at p comma 0. Well, you just added 0 plus p, and you got p. Well, now we've got to add h to p. All right?
Always talk about P's have to make me P.
Of course. Yeah. All right, what about the directrix? Where is the directrix going to be? H, what? Minus p, that's right. Yes, very good. Very good. If p is greater than 0, we're still going to open to the right. If p is less than 0, it's going to open to the left. I don't like where that is. I like that better. Alright, there's my vertex at HK. So what's the distance from here to here? That distance has a name. What's that distance? Yeah, it's P. From here to here is P. P units. I don't know what that is, but that's how far it is. So that's H plus P, comma K. The distance from here to here is how far? P units. Yep, it's the same. So this line is X equals H minus P units. And this is when P is greater than 0. So here, do a less than 0, the skinny one. Probably so skinny I don't have room for all my stuff. What's this point right here, the vertex? What is that? HK. Yes, that is HK. What's this point, the focus? H plus P, comma K. What's the equation of this line right here, the directrix? Right. Good, very good. Okay, so okay. Vertex, focus, directrix. Vertex, what's HK? 2, negative 3. Here's H, here's K. Alright, in order to get the focus, I need to know what P is, right? What's in the P place?
1/2.
1/2. Okay, so does that mean P is 1/2?
No.
No, that means 4P is 1/2, right? Okay, so what do I do? No, divide by 4. Divide by 4. 4, and P is 1/8. Okay, X is being squared, right? X is being squared. So let's look back on our X is being squared. Our focus is at H, comma, K plus P, right? So it's going to be at H, comma, K plus P. Negative 3 plus 1/8. Negative 2 and 7/8.
What fraction that is now?
Okay, that's right. Alright, the directrix is at y equals, don't forget that y equals, don't forget that y equals, K minus P. So that's going to be K minus 1/8. What's a negative 3 minus 1/8?
Minus 3.
3 and 1/8. Oh, I'll put it like this. So let's just sketch a graph of this, okay? Just a quick sketch. Over 2, down 3. And I have a focus at 2, 2 and 7/8, and a directrix. Okay, so that's what I have. Which way does this open? Up, down, left, right. Up. Okay, 2 ways to know that it opens up. One way, E is positive, X is being squared, and P is positive, so it opens up. The other way, the focus goes on the inside, okay? Like that parabola is a mouth about to swallow it, right? So that should tell you that it's going to open up. The directrix is outside, just below it or beside it or whatever, okay? All right. Now that's an easy one. They're not easy like that, unfortunately, for